We did that last week.
Yeah, we did that Friday,
right?
too.
Yeah. We thought it was going, and then we went, what, 15 minutes, and we're like, okay, time to submit, and didn't even start it, so... And then we just made like a 10-second video, like, hi, bye.
That's funny.
Technology.
Anyways, okay, now we're on number 1. All right, so that equals something, right? Is that what we determined?
0.02 in for x. Is that what you're saying?
Would it?
Yeah.
Yeah, I think so, yeah.
Yes, I believe so.
So that comes out to be 0.9996.
Yeah. Wait, say that again?
1 over 1 plus 0.02 squared.
Yeah. Yeah, that sounds right.
0.9996. And with the calculator, when you just take the inverse tangent, 0.02, it comes out to be 1.145.
Mm-hmm.
That sounds right.
Yeah. And, okay.
Should we write it up on the board then? I think that's a yes.
Yeah, do it.
That way, in case people watch the video with the sound off.
That's what I like doing. I like watching videos without noise. That's my favorite thing ever.
People legitimately do that.
This is true.
Where like you're doing multiple things. Like you're watching the video and then you're actually
There's other
watching
people
the
in the
video.
room and stuff. And
Yeah.
they don't want you watching the video unless you just turn off the noise. It's the best way to watch Dragon Ball Z. No, I'm just kidding. I'm just kidding.
Okay. So then what we want then is j of -1, 0, 2. Then equals. Actually, I'm just going to put a variable in there instead of a number, And then equals x prime over 1 minus x squared.
Is it 1 plus x squared?
1 plus x squared. Wait.
Because 1 minus x squared would actually get you closer.
Yeah, it should be 1 plus x squared.
Yeah, if you get minus, you're slightly closer. Not by much. But.
You have to realize division of the last day and a half has been just subtracting over and over and over again for me. Let's divide 1,000 by 11. Subtract 11. Are we there yet? Nope, keep going. Which then gives us 1 over 1 plus x squared, which then equals 1 over 1 plus 0.02 squared, which then equals 1 plus 0.004, which then equals
1 more 0 there, if I'm not mistaken.
Well, what was the answer that we got?
Yeah, so 3 zeros, 0.0004.
Because we got like 0.9 something there.
3 nines and then a 6.
And then the calculator got was
1.1458.
1.1458.
Uh-huh. .1458 equals 0.99.
Yeah.
Just gonna point out.
That's close.
I accept it.
Oh, looks good to me.
Yeah.
Our margin of error is what, like 0.25? Actually, that's
0.15.
0.15.
Mm-hmm. It's pretty good.
Oh, here we go. My favorite problem, the angles.
Dude, so did you watch the video from Friday?
No, honestly, it was pretty good.
It's like NASA or something.
Wasn't that the one that you guys did like 10 the 10-second long video?
No, well, I think what happened that day was like we had started it,
But it didn't
only to
start.
find out that we didn't actually like start it
Uh-huh.
because we were doing it on your laptop at first
And then
with the
it
broadcasting.
died.
Yeah, like
So you got some of it. And then...
we had started it, but we didn't realize it wasn't recording anything. It was just like doing like a little charger thing so we could broadcast.
Buffering or
Oh,
something,
yeah. And we didn't realize we didn't actually start it, and then he started it, and his laptop died.
It was
One
a
thing
bad
after another,
day.
huh?
It was such a long
Jeez.
day.
It was a Friday,
Yeah.
so
That's
what
funny.
else? Okay, so that was number 1. Yo, number 2. A surveyor standing 30 feet from the base of a building measures the angle of elevation to the top of the building to be 75 degrees. How accurately must the angle be measured to estimate the height of the building within 2%? Say what? Okay, I'm gonna draw myself a picture, yo.
That's what I just did.
Nice.
Well, how tall is the surveyor? Just kidding, that doesn't
We
matter.
just assumed that he looked from, the ground. His head was just laying on the ground and just looking up. 30 feet.
I don't know, man.
That's a weird question.
So 2 degrees of the height of the building. Is that what they mean?
2%.
Mm-hmm.
What the
How
hell?
accurate must the angle be measured to estimate the height of the building within? Okay.
So is this asking, like,
So like
essentially how many decimal points?
basically like so 75.1 degrees or 75.5 degrees. Like how
Okay.
much of a difference will it make in within a range of 2%? Which is
How did we solve it Friday? Did we solve it Friday?
I think it was an equation we did. I don't know if we got an exact value. Sorry, I'm going off on a tangent. Are you into the lightsaber thing also? What do they call the?
Lightsabers?
Well,
Star
it's-
Wars?
Well, like,
Wait, what are we
yeah,
talking-
Star. No, it's a company that you can buy those.
Oh, no.
Okay.
No. That was... So...
This is screaming like Star Wars.
The whole lightsaber thing. That was good.
The Battlefront beta opened up,
Mm-hmm.
and even though I have nothing to play it on, there's no reason not to be excited about it,
Uh-huh.
I remember playing Battlefront 2. That was a lot of fun. Especially when you play enough to where you have, like, all the perks unlocked. And so you just have, like...
Just destroy.
you just have, like, unlimited shotguns and stuff. And then your friends who don't have the game, then they don't like you. Because then you always win. Okay, so I feel like this is one of those integral thingamajigs.
Well, we're working on derivatives right now, not integral with this, aren't we? Because it's called the derivative apps for trig.
Right, but I feel like that's what this is going to turn into.
Okay.
Because we have to find the change in our x here to find out how much it can vary,
Okay.
Which means that essentially we have a range of like x plus 0.35x and x minus 0.35x, I'm just throwing out ideas. Maybe one of them will stick.
If 75 degrees was accurate, then it'd be 30 tangent of 75 is the height of the building.
Say what?
So
Marker time. Yes. This is the best.
this is fast. So here, what's that marker?
Oh.
This isn't working. It's black.
Oh no, that's fine. The screen just fell asleep. The light's on.
So you have, that's 30 feet away, 75 degrees. And then this is your H, right?
Mm-hmm.
And we don't know what that is, the height of the building. So tangent, since you have your 30 and your opposite and adjacent, tangent of 75 is equal to opposite over adjacent.
Oh, okay,
30.
okay. I see what you did. You skipped over this part of it. We
Right.
just went straight to 30
So,
tangent.
right,
75.
so
okay.
30 tangent 75 is equal to the height. Well, the height needs to be within 2%, so I just kind of threw it out on a limb. I don't know if this is right at all, but 2%. I mean, I don't know if that's at all what we're supposed to do, but that's just me thinking, all right, well, that's how you would kind of plug that in. So dH dx, but then how do you plug h into this and then take the derivative of it? It's kind of where I got so far. I don't know if that's any
So
good.
that makes sense.
But
That makes complete sense.
kind
I would agree with the.
I concur. Now what's the
I
answer?
don't know where the derivative part comes in.
No, I don't know.
Because that would make sense that we have the angle, which would give us the height, and then.
Mm-hmm. See, but then if you take 30 tangent,
0.02 of that, both positive and negative, that would give you your range. You know.
mm-hmm. So right now, as is,
I'll just write it up here.
I have that the height is equal to 119.96.
And that's the third tangent of 75.
Yeah. But within 2%, you wouldn't use derivative alone, then I would just take 2% of that, but
Yeah, that's what I was thinking. It would be take 2% of it.
that's not using the
subtract it
derivative
back.
whatsoever.
Yeah, yeah, not at all.
That's just trig you're doing there.
Well, I mean, we wrote dh over dx over there, so that's a derivative. So I
Plug that in. That's why I was kind of thinking like,
But
what if-
maybe that is all that we're supposed to do.
oops, that's an awkward name. I'm almost wondering if there's, like, if you take 30 tangent 75 minus h is equal to 0, then if you take the derivative of that, then that's when you would get whatever that minus dh over dx. And that's when you would get your point 2. So if the derivative of tangent is what?
The derivative of tangent is
Is
the
it
secant
secant
squared.
Yeah.
I wrote it down over here someplace.
So you have
Oh, dang it. Don't play my laptop. Well, I did write it
it's
down.
30 is a constant then, isn't it?
Yeah,
Yeah.
So it'd be 30
there we go.
secant squared. It wouldn't just be 75, would it? 30 secant squared 75 is the derivative of 30 tangent 75.
Yeah, I believe so.
Let's just try it. So 30 secant squared 75. Where's that weird angle? Secant squared 75 minus dh dx.
And dh of dx is
Or
0.02,
that's
right?
0.02, yeah. What's 30 secant squared? Secant squared is equal to
we get the same answer as what we got up above it.
We shouldn't we?
Oh no, but if we do, man.
If we do, it'd be awesome.
If we do. I'm just gonna go back to check. No, I'm just kidding.
How do you do secant squared on this?
That's a good question.
That's what I couldn't figure out how to do secant, cosecant, cotangent. If you can.
If you can, I know you could do the inverses, but that's good.
Well, what's the equation for secant squared?
That's what I was wondering.
Well, that's what I'm wondering.
Seeing that.
Isn't that secant 10? Let's see.
So, what was this? Derivative of inverse tangent x is equal to u prime over u.
It's 2 tan x secant square x.
What is it?
2 tan x secant squared x.
Secant squared x.
Mm-hmm.
Like what?
That still doesn't help us, does it?
Isn't that but that's the derivative though of secant squared, isn't it?
No, this is Wolfram alpha.
So
Sometimes
that's just what secant squared equals.
Yeah.
But
Derivative,
secant squared
yeah.
can't equal itself.
So
can
what is just secant squared? What is that equal to?
I guess better thing would be a secant of x. Search.
That's interesting.
Oh, I think I might have found it, homies. Secant of x is 1 over cosine of
Well, what's
x.
secant squared of x?
1 over cosine of x times 1 over cosine of x.
1 over cosine of x.
1 over cosine.
Because secant squared is just
1 over-
secant times secant.
Yeah, right. So it's 1 over cosine x?
Yeah.
Oh, duh. Yeah, because cosecant, secant, cotangent. So
I'm glad that made sense to you.
That's so. Let's just know this. So it's just kind of what they match up to. The sine is goes with secant or cosecant. Cosine goes with secant. Cotangent goes with tangent.
Yeah, yeah. That part made sense.
Right.
I was like, well, I'm glad you just
Yeah,
pulled that out of there. Out of your head. I'm just kidding. 35 over cosine of x times 1 over cosine of x.
Where x is 75, right?
Yeah. Minus dh over dx equals 0. Gives us 30 times cosine of 75. Cosine 75 minus 0.02 equals 0.
Would you still have it equal to 0? Or are we just saying that's our equation? Go with it. You still want to have it equal to 0 because then we're not really solving for a variable. Does that make sense?
It does.
I
I have it equal to 0 because this is going to equal something, you know?
Might as well have it equal to 0.
Yeah.
It makes it easier.
Yeah, we don't want it to equal
That's
0.
fine.
So we're trying to find
Cosine 75.
how accurate of an angle we need to be within the 2% range of.
Correcto mundo.
Okay.
Let's go.
And I got 111.96. I don't know if I did it wrong.
Whoa, I got something else.
Whoa, I haven't done it yet. 30 divided by
Yeah, I got something totally
cosine
different.
5.
Are you in
minus
radians or
cosine
degrees?
sine 5.
Let
Oh,
me
crap.
check. Should be in.
Delete.
Yeah, because cosine 75, I got 0.2588. Now I squared that. So what I did was 30 times 1 over 0.288. Right? 1.2588. I squared that. That's 0. That's what I did.
Yeah, definitely get anything anywhere near what you guys got.
What'd you get? When I did it all, I got 447.
Oh, hey, that's what I got.
447.826.
Yep. That's what I got. I thought you said you got like 20 something.
So you go.
Yeah.
Sweet.
How accurately must the angle measure to estimate the height of the building within?
Wait, we solved something else, didn't we?
Yep. So how accurate must that angle be? What if we did?
So this is where I think, like, if we go back to our equation where we got 119.96.
And then we just plug x into here and solve for it to figure out how accurate that needs to be.
Well, we first have to find the range of our height. Does that make sense? So, like, this is, I think we'd have to times it by the 0.02.
That?
Yeah. Both positive and negative 0.02. That way we can get, like, the lowest the height could be and the highest our height could be. And then plug those back into our tangent. Does that make sense? So, like...
And then, okay, but then that's still trig.
Yeah, that's the thing. Like,
I see what you're saying.
I feel like that's still our best option here.
Tangent of whatever that angle needs to be equal to 119, or I'll just do 119.
Yeah, 119 times
119.9
plus or minus
0.02, yeah. And that's so you would just get x is equal to the inverse tangent of whatever that is. 119 point. Is that what you're saying?
Yeah, probably.
That's not using calculus at all.
Nope, not the slightest. But we'd have an answer.
Would have an answer. I don't know whether or not it's the right answer. Let's see what that gets us now. I'm just curious.
Yeah, because definitely our range is not going to be 447.
No kidding.
I don't think he's allowed to do front flips before looking at it and have that count.
Wait a second. I got 111, not 119.
Yeah.
Sorry about that, guys.
It's okay.
111. So that times 0.02 and take the inverse tangent of that. So if you do that, the inverse tangent of positive 0.02, you get 65.935.
Or about 80. Or 85, 86.
I just get negative after that. I get negative 65.9835. So then you subtract 70, you subtract that from 75, then you'd get 9.065. Maybe that's the range you need to be in. That's still a wide range though.
That it is.
You need to be in this 18-degree area in order to get it right like that. It's fairly wide.
But even 75 is like that.
Mhm.
You know?
Mm-hmm. So then 65 is lower, you know. And then 84 is,
It's going to be way giant.
you know, nearly 90.
Did we just think about this problem too hard?
Probably.
It's actually way simpler than what we wrote down here. This is really just a dot B kind of a problem.
It's a dot B problem. So you get 9.065.
So ends up being 84.
That's what I'm saying. Like it's just.
No, that's what I'm saying.
Oh, nice. I like it. It'd be 85, wouldn't it? Yeah. Or 75 and then 84065. I think we're thinking too hard about it.
It's okay, I excel at doing that.
You excel at doing that.
It's one of my specialties.
Let's try this up here just See, and I don't know why, but you can divide that by 111 just, just cause. There's your dot B. And then you'd get basically 4.
Mm-hmm.
So it's 4 degrees, you have a 4-degree margin. That's a lot better than
That's
9.
a lot better.
I'm just, I don't know. I don't like this chair here. I can't roll around without the table. I don't know, guys. Everyone's got an idea? Because now it just looks like a mess.
Yeah, I don't know.
So the surveyor's a guy, right? So he's a... we don't know how tall he is. That's our problem. He's got a worker's hat on.
As it turns out, he's 20 feet tall. That's why the height is so great.
Alright, we'll be kind. It's a female surveyor. Let's not be sexist or anything here.
I'm wearing a dress.
She's professional, okay?
Let's go on to number 3.
Yeah.
Okay.
For the last 5 minutes that we're here. Cars on a certain roadway travel on a circular arc of radius r. In order not only to rely on friction alone to overcome centrifugal force, the road is banked at an angle of magnitude theta from the horizontal. The banking angle must satisfy the equation rg tangent of theta equals v squared, where v is the velocity of the car and g is the acceleration due to gravity. Find the relationship between the related rates dv over dt and d theta over dt. Wait, do we have dv yet? No, we don't have dv yet. So the first thing we want to do is find the derivative of that bad boy.
So R's constant.
Mm-hmm. And G is a constant as well.
G can change, can't it?
Well, G is gravity.
The
that's a
acceleration due to
constant.
gravity. Okay.
Yeah, so G is a constant as well.
G.
V, however, is not a constant. And, well, in reality, tangent's a constant in this thing. It's not like we're going to start changing the bank. Hey, we're back to secant squared. How exciting is that?
Erase this. So I initially drew the arc, which is now it was a lot better on my paper. You don't really need that though, do you?
I think so.
But illustrations help. Maybe. So we get the equation. And for the derivative, like Rg secant squared theta d theta over dt is equal to 2v dv over dt. Is that right?
That's what I got.
Okay, and then you would just find the relation between the two?
Yeah.
So then you would get dv over dt is equal to Rg secant squared theta d theta over dt all over, right?
I think so.
And same thing with d theta over dt is equal to over Rg.
Right? Yeah. I'm sure I got the third one because I know I got the second one. If that makes sense.
What third one?
So like, because I got the dv over dt equals blah blah blah.
Uh-huh.
I know I got that. So I assume I got the other one. That's below it.
Uh-huh. My question is that what? For some reason, something's telling me that you don't just take that top and then just put secant squared in for tangent. For some reason, that just doesn't look right to me. I mean, it could totally be correct and everything, but I mean, if that is correct, then that's what you would come out with for their relations one with another.
I think that's correct.
Okay.
What
That's
say you,
fine.
Patrick?
I think so. Yeah. Just like going through it, it looks accurate. I mean, like everything's where it should be.
Uh-huh.
Yeah, because this is just asking us about rates of change.
Yeah.
And then the relation of the
Of the two.
Right.
two derivatives.
For the two other rates.
Yeah.
Not actually trying
Awesome.
to solve anything.
Yeah, I'm not
Thank
trying to
goodness.
find anything.
Yeah.
Well, if you do, then you just plug it in.
Yeah.
That's
Or-
a lot.
yeah, like the one that we actually figured it out correctly is the one we don't have to figure anything out.
Kind of convenient.
Alright.
Oh,
I think we're
we
gonna
gotta go.
Yeah.
Okay.
Sweet. It's been fun.
I should write this down really quick. dv over